Okay, so here's example 8, the quota problem. Junk bonds, also called high-yield bonds, can be profitable as well as risky. Suppose you consider only companies with a 35% estimated risk of default, and your financial investment goal requires 4 bonds to be good bonds in the sense that they will not default before a certain date. Suppose you want to be 95% certain of meeting your goal or quota of at least 4 good bonds. How many junk bond issues should you buy to meet this goal? So the probability of default is 35%, which means the probability of a good bond, which is what we're looking for, is 65% or 0.65. Let success S be represented by a good bond. Let N be the number of bonds purchased. Let R be the number of good bonds in this group. We want the probability R greater than or equal to 4 to be greater than or equal to 0.95. So in this case, it's easier to calculate, or more, I guess, quickly to calculate if you use complements. So the probability of R greater than or equal to 4 is the same as 1 minus the probability R is less than 4, which is 1 minus the probability R equals 0, minus the probability that it equals 1, minus the probability that it equals 2, minus the probability that it equals 3. So in other words, we're looking at 1 minus the probability less than or greater than or equal to 4 is the same as 1 minus the probability that it's less than or equal to 3. All right. And so we're looking at the probability that it's either 0 or 1 or 2 or 3. So I'm going to pause it and bring up the probability table here. All right, so here's your probability table 3 in the back of the book, the appendix 3, I should say. And so the probability of R successes in N independent trials, each with the probability of success P, okay? And so your N values are going down the side, okay? And then here's your R values. And so what we want to do is go across at the top to where the probability is 0.65. So we're interested in this column right here, okay? And so the idea is, for example, the probability that we're looking for would be 0, 1, 2, or 3 is being subtracted from 1, right? So the probability, like if you pick N equals 4, and look at R equals 0, 1, 2, 3, we're subtracting those 3 probabilities in this column. So 1 minus these probabilities here from 0 to 1 to 2 to 3, and see if they are at least 95%, 0.95, right? Or greater than or equal to 0.95. And if you subtract the sum of these from 1, you don't get 0.95. So you would go down to where it equals 5 and see if that works, and it doesn't. You'd go down and see where N equals 6 and see if 1 minus the probability of 0, 1, 2, or 3 works for those, and it doesn't. Okay. Let me make sure of what column we're in here, 0.65. And you keep on going down for the probability of 0, 1, 2, 3 that you're subtracting from 1 to see if it's greater than 95%. Well, that doesn't happen until you get down to the probability that it equals 10. All right. So for the 0.65 column, if you take the 1 minus the probability of 0, which is 0, 0.000, 1 minus the probability it's 1, and the probability it's 2, and the probability it's 3, Let me pause it and change screens and tell you what you get. Bulky. All right. So I'm going down this 0.65% probability, or 0.65 probability, I should say. And it works when I get to 10 right here, okay? So here's a probability of 0, 1, 2, and 3, right? So now let me go back to that other screen that I was just on. So we have 1 minus the probability of 0, minus the probability of 1, minus the probability of 2, minus the probability of 3. We want that to be greater than or equal to 0.95. So going back, if you look back at that binomial table where n is 10, that's going to be 1 minus the probability of 0 is going to be 0. The probability that r, that's your value for r, the probability r equals 1 is going to be 0. The probability that it equals 2, if you look at the binomial table, is 0.0004. The probability that it's 3 is 0.021, excuse me. And so if you calculate that, you get 0.975, right? We wanted it greater than 0.95. So this is the first value when n equals 10, where you get something that's greater than 0.95. So this is what you pick right here, the where n equals 10, and you get 0.975. So 10 is the smallest value of n for which this particular condition is satisfied. So under the given conditions, you can be 95% sure. So that's at least 95%, right? Or greater, whatever is immediately greater than that it hits on the binomial table. You can be 95% sure of meeting your investment goal with n equals 10 junk bond issues. So again, we're back here at the 10. Where's n equals 10? Here we go. And it's this column right here. So it's 1 minus the 0.000, minus the 0.000, minus the 0.004, minus the 0.021. So that's the one you want to pick, is n equals 10. So that's an example of a quota problem. And again, note the procedure, keywords to look out for on page 214. And then here's your recommended homework problems number 13, 15, 19. Just do parts B and C, and then number 23.